Hey guys, video 2 about Lewis structures. We're going to talk specifically about resonance, formal charge, and a couple of exceptions. So here we're looking at this particular example of an atom that we drew in the last video. Now we're looking at it and we're asking ourselves, is this the best way to truly draw these things? Sometimes what happens with molecules and what happens with electrons is that they can create what's called and IB really likes this terminology, it's called a coordinate covalent bond. And what a coordinate covalent bond is it's taking two electrons from an atom, from a species, and it's going to satisfy an octet somewhere else. So it'll take these two electrons and it'll create a second double bond in between sulfur and oxygen here. So if we were to redraw this now, it'll have a scenario where it'll have a double bond up top and we'll have chlorine and chlorine out to the sides. When we do something like this, when we actually change the position, you might ask yourself, well, what is the better option, right? What makes one thing better than the other? And it has a lot to do with stability, right? And so I'll answer that question in a moment here, but first I'm just going to give you a little bit of a chat about resonance. You'll find that this happens in this thionyl chloride group, so this is what this SOCl2 is called. But it also can happen in ozone as a separate example. So you can see something where we have an already present double bond connected to a central oxygen atom, and here would be the proper Lewis structure for it with all of these electrons. Now, what actually can happen is that a coordinate covalent bond can create itself on the opposite side of the already existing double bond, and from here that'll actually push this existing double bond to be creating into a lone pair. Now this is a little bit of a cool example where you will have something that will be sharing double bonding capacities, right? So you'll have something that will look like either the molecule here or it'll look like the molecule on the right. Now we need to ask ourselves, which is the proper one? And really in its truest form, the way that the electrons are behaving is probably somewhat like this, where they really are kind of creating bonds of almost 1.5 times strength of a regular bond. So if you were to think of it like this is where we actually get the idea of what's called delocalized electrons, right? And so delocalized electrons, this term may not be used very much in topic 4, but when we start getting into more organic chemistry, it'll definitely come into play for sure. So this is a general form of what resonance is all about. Now, if we were to take a second to figure out something, what's called formal charge. Now I'll redraw those thionyl chlorides where I had my oxygen here, and I'll redraw the whole little bit. Give me one sec. And we had our second one that had our double bond. Now, which of these is a more stable and therefore more correct representation of this Lewis structure? Now, the way to do this is really to consider what is the formal charge. Now, really all the formal charge is just the number of valence electrons minus the number of unshared valence electrons minus 1/2 of the shared groups. Now, I'll look in specific here with this relationship between sulfur and oxygen for both sections. Now, let's look at oxygen in specific. Oxygen right now has 6 regular valence electrons that it brings to the table, and it has 1, 2, 3, 4, 5, 6 unshared electrons, and again I'm dealing with this oxygen over here, and again it's sharing just 2 electrons inside of its bond. So it's actually going to be just 1 for that value. So the overall total here for this is going to be a -1 charge. All right, so if we do the same analysis with the molecule on the right, though, we might get a different result. So here we will have the 6 valence electrons, again, because oxygen brings 6. We have 4 unshared electrons. We have 4 unshared electrons here and here. And we have 4 bonded electrons, but we're going to take half of that, so -2. And this right here, overall, is going to have a formal charge of 0. Right? So we ask ourselves throughout the entire molecule these values, and we say which one of these is going to have a more stable resonance structure. It's the one with the lowest charge. So here on this group, there's actually a formal charge of 0 on these chlorines and a formal charge of 0 on these chlorines as well. And same with the central atom of sulfur. A good exercise for you in this video may be to figure out what is the formal charge on all atoms of this molecule right here, right? So that could be a good way for you to test yourself.